Okay, welcome to the first revision video for paper 2. I'm going to be covering those topics that weren't there in paper 1 for you. So this video is about trigonometry from paper 2. I'm going to be solving a range of questions and then, taking you through all the tips and tricks that are there. Okay, so the first question is from this is June 2019, paper 2-1. This is PQRS is a trapezium with PQ parallel to SR and SPQ equals to 90 degrees. So whenever you see parallel lines, your first gut feeling should be that they are going to be two sort of alternate angles or corresponding angles, whatever the case might be. It says calculate PS. So PS is this side. Let's call that X. It's a right angle triangle, so I think that's relatively simple. I can just use cos 58 equals to x over 15, since I have the adjacent and I want to find the adjacent and I have the hypotenuse. So this becomes x equals to 15 cos 58. Now doing this gives you the most exact answer. I could just calculate cos 58 and sort of write it in decimals, but make sure to write some extra decimal places. What the examiner generally writes in the examiner report is that if you're doing an intermediate calculation, that's not the final answer. You should write 4 significant figures instead of 3 significant figures, just so that when it gets rounded off, it gets rounded off to 3 significant figures. So this gives me 7.94, basically 88, rounded off to 3 significant figures would give me 7.95. So that's my first answer. Then it says calculate the obtuse angle S or Q. So I'm going to first mark that angle. Let's call that Y. I want to find this angle. Now, what I notice is that right now I can't use the cosine rule because I need this third side. If I want to find the if I want to use the cosine rule, then I have to somehow end up using the sine rule. For the sine rule, if I have this opposite side, I can keep this angle, but I must have this angle then in order to keep this as the opposite side. So what I notice is there is a pair of parallel lines which I asked you to notice first, and I can just calculate this by subtracting the other two angles from 180. So 180 minus 90 minus 58 will give me this as 32. If that is 32, this should also be 32 because you see there is a Z forming, which means that they're alternate angles. The line was marked parallel. If this was not marked parallel, I wouldn't have been able to do that. So sine 32 over 11 equals to sine y over 15, making sine y the subject. I just cross multiply. Then I have to take sine inverse of this. Now again, I'm getting you the best possible answer without any rounding off errors, which is why I'm doing it like that. Should do it like that on the exam as well, so that you get the most accurate possible answer. You see, your calculator can calculate the entire fraction. You don't need to worry about that. So y is 46.270. Okay, so 46.3 is the value of y, but I wasn't looking for an acute angle. I was looking for an obtuse angle. So what I'm going to do is I'm going to subtract it from 180 and say that in order to work through this, that I have to find an obtuse angle. So 133.7 degrees, answers in degrees have to be correct to 1 decimal place. That's the requirement of the exam. So 133.7 degrees. Remember that this often happens in the sine rule, where you get an obtuse angle or an acute angle and you have to find the other one. You generally get an acute angle from the calculator. So in order to convert it into an obtuse angle, you just subtract from 180. This only happens when you've applied a sine to some number and so you're sort of finding an angle. Okay. So the next question is this from the same paper. It says the diagram shows the position of two ports A and B and the lighthouse L. The bearing of B from L is 062. So that's the bearing that they're talking about. It says AB is 13. Calculate the bearing of A from L. So I need an axis on L that's already drawn. I'm just going to stretch it and I want to find this basically bearing. So in any case, I have to find this angle X. So what I'm going to see is I have 3 sides and I want to find an angle. And when you have such information, you have information in the format SSS. I'm not talking about congruency right now. I'm just telling you how the information is placed. So if you have 3 sides and you're looking for an angle, then you apply this cosine rule. Now, if you remember the cosine rule, it's cos c equals to a square plus b square minus c square over 2ab. That's a modified version of the cosine rule. Maybe you've learned the one that's in a single line, and that's absolutely fine. I just find this more convenient in finding angles. So whatever angle you're trying to find, you place the side opposite it with a subtraction sign. So I'm going to subtract 13 square. I'm going to add the other two. I'm going to say 14 square plus 8 square. That's how I sort of learned my cosine rule. 2 into 14 into 8. Again, I can keep the answer very precise. Cos inverse of 14 square plus 8 square minus 13 square over 2 into 14 into 8. Now, you've got to understand that 4 marks, wherever the question will be for a cosine rule application, it's going to give you 4 marks. What are those 4 marks for? There are 2 marks here. So you've got to plug in the formula right. You've got to have the sides in the right order and everything else. If you don't do that, you don't get the 2 marks. There is 1 mark generally for doing an inverse, and then 1 mark for writing an answer. So let's take out a final answer. Cos inverse of 14 square plus 8 square minus 13 square over 2 into 14 into 8. 66.0305. So 66.03. Let's keep it at 03 right now because that's not my final answer. I want to find the bearing. So the bearing is going to be 62 plus 66.03. That gives me 128.03. I don't need to write more than one decimal place. I'm going to write 128 degrees is my bearing. Okay, let's check if that is the right answer. 11A. Yeah, that's the correct answer. So let me show you the marking scheme as well. You see M2 for cos L equals to this. That's what I told you, the 2 marks for this. And if you write it in the wrong order, then you get an M1, you don't get a full mark. Oh, okay. In fact, making cos L the subject is also 1 mark. Okay, and you get another mark for writing the correct answer. It's a weird marking scheme though. Okay. So a bird is located at C. AC is 11 kilometers from B, and BCA equals to 90 degrees. Okay, so you don't see C in this question. The boat travels to port A in a straight line. Okay, so we'll have to find the distance the boat travels. Okay, so I will have to find out where C is. C is 11 kilometers from B, and BCA equals to 90 degrees. So the angle at C is 90 degrees. So can I say that C should be somewhere here? This is 90 degrees. So let's draw that like that. Okay, so that's 90 degrees. That's C. And where is C? C is 11 kilometers from B. So 11 kilometers from B. What is the boat trying to do? The boat travels to port A in a straight line. So the boat is going like that. So I'm asking you to find this. This looks like a very simple question. It's also just 2 marks. So I have the perpendicular, I have the hypotenuse. Can I just apply the Pythagoras theorem and get you the final answer? That's plain and simple. So AC square equals to 13 square minus 11 square. So AC is basically root of, what's the root of? 48. So root of 48 gives me 4 root 3. Or if I were to write it correct to 3 significance figures, it's 6.93. 6.93. 6.928 or 6.93. The boat then travels in a straight line from port A to port B. So now it's going from A to B, that's 13 kilometers. So distance is 13 kilometers. It has an average speed of 3.75 kilometers per hour. Calculate the time taken for the boat to travel from port A to B, giving your answer in hours and minutes. So it's a basic speed time question. Speed equals to distance over time. So 3.75, 13 kilometers. I don't know the time. Let's call that T. So 13 divided by 3.75. That gives me 3 point, let's do that. It gives me 3 whole 7 over 15. So that's 3 hours. 7 over 15 in minutes would give you into 60. 28 minutes. Okay, so that's my final answer. Let's check our answers quickly as we go to the next page. 6.93 and 3 hours and 28 minutes. So that is your final answer. Okay, that's the next paper then. This is June 1922. It says the diagram shows the position for two boats A and B drawn to a scale of 1 to m. Okay, the loci. So I can't really go on and do this part of the question, but I think I kept it for the next part of the question. So I'm going to move there. This is the second part of the question. It says the diagram shows the position of the boats A and B and a harbor H. Calculate AHB. So I'm asking you to calculate this angle. Let's call that X. It's a 3-mark question. So it's either the sine rule or the cosine rule. I think it's the sine rule because I see two angles now. So I'm going to say that sine X over 4 equals to sine 70 over 6. Sine X equals to 4 sine 70 over 6. Sine inverse of 4 sine 70 over 6. That gives me X as 38.7896, let's say. So that gets rounded off to 38.8 degrees. Then moving on, it says the boat travels in a straight line from harbor. At H, the average speed of the boat is P. This boat is traveling, so 6 kilometers. So the distance is 6. The speed is P. It takes 12 minutes and 20 seconds for the boat to travel from A to H. So I need the time in hours. So I'm going to say that 12 minutes get divided by 60 and 20 seconds divided by 3600. So that gives you in hours. So 12 divided by 60 plus 20 divided by 3600. Okay, that's 37 over 180. I'm just writing exact values just to be sure. So speed is distance over time. So 6 divided by answer on my calculator. This is coming out to be 29.189, which is 29.2, I guess. 29.2. Let's check if our answers are correct. Yes, our answers are both correct. 38.8 and 29.2. Okay, moving on to the next question on trigonometry. The diagram shows the positions of three farms A, B, and C that lie on horizontal ground. Farm B is on a bearing of 125 degrees from farm A. AB equals to 90, 950, BC equals to 680, and so on. All of these are in meters. Show that BAC. So I'm asking you to prove to me that this angle is 44.0 correct to one decimal place. Again, I have three sides. That means I'm going to use the cosine rule. So cos x, this one gets subtracted, the one opposite it gets subtracted, and then 520 squared plus 950 squared over 2 into 520 into 950. So x is therefore cos inverse of 520 squared plus 950 squared minus 680 squared divided by 2 into 520 into 950. 44.017. So one decimal place is 44.0. Okay, that is my final answer. So I've shown, so you can just make a box over it, and that proves to you that you've shown. Calculate the bearing of A from C. So I've got to have a vertical line at C from C. So what I am then trying to do is, it's just a 1 mark question, which means that the answer is pretty plain and simple. Bearing of A from C. So when I'm saying from C, so I'm asking you to measure this entire angle. So in order to measure this entire angle, can I just find this small angle? And this small angle is basically going to be from alternate angles. If you have x, you have 125. In fact, all of you have x, because that's what the question told you. So 180 minus 125 minus x, which is 44.0. So what do I get? 11. Okay, so the bearing of A from C is 360 minus 11, which is 349. Okay, let's verify if those are the correct answers. This was 9A and B. So 9A and B, 349. That's what I said. And 44.0 is something that we've proved. Then it says form A and B are joined by a single straight track AB. A mirror walks along the track from A at a constant speed of 4.6. Okay, this question is about speed time, but I want to do the next part as well. So I'm just going to go on and quickly do this. From A at a constant speed of 4.6. So A to B is 950 meters. So 950 meters. Since I see the speed in kilometers, can I just say that this is 0.950 kilometers? That's the distance. And calculate the time it takes for a meter to walk from A to point B, that is closest from, okay, calculate the time from A at a constant speed of this. Calculate the time it takes for a meter to walk from A to the point that is closest to form C. So what is the point that is closest to form C? Let's talk about that. So this distance is going to be the closest when it is exactly 90 degrees. So what Amira is doing is she's not going the entire distance. She's just stopping here, which means that I need to find this length y. Okay, how am I going to find this length y? I have the angle, I have the hypotenuse. Can I find the adjacent? Yes, I can just use cos, and I'm going to use the exact value. I'm going to say that cos 44.017 equals to, I'm going to use them in now kilometers rather than meters, because I know that's what I need. So y over what was it, 520, 0.520. Why? Because that's the point closest to C. That's the shortest distance between C and the line AB. Remember, the shortest distance is always a perpendicular line. So 0.520 multiplied by cos of 44.017. 0.374. 374. That's the kilometer distance. I have to find the time correct to the nearest in minutes and seconds, basically. So let's just find it in hours first, and then we'll have to change it into minutes and seconds. rather than I haven't changed this, so let's just stick to what we have. Speed equals to distance over time. Okay, so speed is 4.6, the distance is 0.374, the time is unknown, so 0.374 divided by 4.6 gives me 0.081304. I'm just writing extra so that I get an exact answer. In order to change this into minutes, I'm going to say that the minutes would be multiplied by 60, so 4.878. Again, I don't need it in 0.878 needs to be changed into seconds, so 0.878 into 60. So I'm just changing some part of the minutes into seconds. That gives me 53 seconds, I think. So verify if we have the correct answer. 4 minutes and 53 seconds. Okay. Okay, then it says a helicopter hovers vertically above form B. So it's vertically above form B. So whenever you have a three-dimensional question, it's best to draw this. The angle of elevation of the helicopter from form A. Now you know that A and B are connected by a straight road, and that's a horizontal road. That's the helicopter up here. And it says that the angle of elevation between the helicopter and this is 10.7. So whenever you have an angle of elevation or angle of depression question, it's best to just sort of draw a separate diagram for it. By drawing a separate diagram, to bring the diagram into 3D. This is obviously a 90-degree angle because it's the helicopter is right above B, so that's what's happening. AB, you already know the distance AB, and that's 950 meters. So okay, so that's 950 meters. Now this question says that you know the angle of elevation, but what do you want to find? You want to calculate the angle of elevation of the helicopter from form C. So you already have this angle of elevation. What you want is that the same helicopter is now being viewed from form C. Do you think B and C are connected? Let's check out if B and C are connected, and you want the helicopter to be at the same place that it was before. So B and C are also connected, and that's a distance of 680 meters. So I'm going to say that now the distance is 680. The angle of elevation is something that you want to find. But in order to find this angle of elevation, I must have the side Y. Let's call that Y. So how am I going to find that? I'm going to first say that I can say tan 10.7 equals to, let's call that height only, h, so that it's very clear to all of us. H over 950, opposite over adjacent. So 950 tan 10.7 equals to h. So I know that 950 tan 10.7. That comes out to be 179.5. Okay, so I can say that this is 179.5. Now, if I want to find the angle x, can I again say that tan x equals to 179.5 divided by 680? Tan inverse 179.5 divided by 680. What do I get? I get 14.8 degrees. 14.8 degrees. I did tan inverse of the entire thing, just to be very clear on this. Okay, I can just write it down if you want. Tan inverse of. Let's check if we have the right answer. Just see, this was the 4-mark question, which means that there was some amount of working that was required. So 14.8 degrees, you can see that's the correct final answer. You have to find out h. There was a mark for finding out h, then there were 2 marks for finding out, in fact there were 2 marks for finding out what h is, and then 2 marks for finding out the angle of elevation. Okay, taking you to the next question then. It says a field is in the shape of a quadrilateral PQRS. A path crosses the field from P to R. PQ is equals to this. Okay, RS is equals to that, PR equals to that, S is on a bearing of 0.42, that's already drawn, PSR equals to 108, and RPQ equals to 38 degrees. Calculate the bearing of R from P, or from P. Calculate the bearing of R from P. So I am asking you to calculate basically this angle, this entire angle. Now, in order to calculate this entire angle, and I'll need this angle X. So I see that's a clear case of sine rule. I have two angles in that triangle, this one and that one. I have this side and that side. I can just go on and quickly apply my sine rule. I can say that sine X over 146 equals to sine 108 over 325. Just for a moment. Okay. So sine X equals to 146 sine 108 over 325. Sine inverse of all of this. Okay, so sine inverse of all of this gives me X as 25.29. Now, what was I looking for? I was looking for the bearing, so that's 42 plus 25.29, that's the bearing. Uh, 45, 42, sorry, 42 plus 25.29. That gives me 67.3. Bearings have to be written with a 0 at the start, so that's 67.3 degrees. Let's check quickly if that's the correct answer. 7 point A should have the marking scheme here. 067.3, yes. Show that QR equals to 202 meters. So where is QR? QR is here. You see you have an angle and the sides next to it, so that's a clear case of cosine rule where you have side, angle and side. So I'm going to say that QR squared equals to, what are the other two? 325 and 280. So 325 squared plus 280 squared minus 2 into 325 into 280 into cos of 38. I hope everybody remembers the cosine rule. C square equals to A square plus B square minus 2AB cos of C. Okay, just move this here. Okay, so QR squared is then, I can just take a root actually. I don't need to do this manually. So 325 squared plus 280 squared minus 2. You see the marks are there for the line that I wrote above. There are no as such marks for the second step that I'm doing. I'm just doing it to show you what I'm doing. So 325 squared plus 280 squared minus 2 into 280 into 325 into cos of 38. QR is therefore 201.512. Round off correct to three significant figures is QR equals to 202. Okay, that's what the question was asking you as well. So 202 meters is my final answer. It says Mia works at a constant speed of 5.5. Calculate the time it takes for her to walk from Q to R. So Q to R. 202 meters, our speed is 5.5, our distance is 202, time is what I want, and I want it in minutes and seconds. I'm going to convert that later on. I'm going to say that speed equals to distance over time. Now, since that was in meters, I can say that it's 0.202, that's in kilometers. So time is therefore 0.202 divided by 5.5. It's best to first come up with a number that you want as your final answer, and then you can go on and change it into well, change it into the required units basically. So 0. So if I were to write this as a decimal, I think okay, let's just write it as decimal. 0.367. Okay, so 0.0367 multiplied by 60. What does that give you? It gives you 2.204. So that's 2 minutes. 0.204 converted into seconds is into 60. So 0.204 into 60. That gives you 12.24. So that's 12 seconds. So I divide it into minutes and seconds that way. 2 minutes and 12 seconds. Let's check. 2 minutes and 12 seconds. That's the correct answer. Let's move on quickly to the next question. You see, most of these questions are in the same format. It's sort of a repetition that you keep coming across over and over again. Okay, let's look at this one. It says ABCD is a field with AB equals to 750 and BC equals to 600. Again, all of these are in meters inside the field. AB is a straight line, AC of length 800 meters, and DAC equals to 90 degrees. Show that ACB equals to 62.9. So ACB, that's the angle that I'm asking you. So this is not a right triangle triangle. The other one is a right angle triangle. So again, I see three sides. I want to prove an angle. I use my cosine rule. I'm going to say that cos x, let's call that x, equals to, first I'm going to subtract the 750. I'm going to add the other two, 800 plus 600 squared, 2 into 800 into 600. Okay, so cos inverse again. Eight hundred squared plus 600 squared minus 750 squared divided by 2 into 800 into 600. That gives me 62.9 degrees. Yes, 62.888. That rounds off to 62.9. So the area of the field is 375,000 meters squared. Calculate AD. So the entire field. So the entire field is made up of two different triangles. It's not a standard shape. I cannot call it a trapezium. I need parallel sides for that. So what I can see is that I need to calculate the area of two different triangles. So let's first try to calculate the area of triangle ABC. So whenever you have a scalene triangle, you can use the formula half into A into B into sine of C. Remember that A and B are the signs are the sides that are next to the angle. So these two sides if you're using this angle. So remember that. Don't end up using a different side. If you end up using 750, it's going to give you the wrong answer. So 600 into 800 into sine of 62.9. So area is coming out to be 213,651.07. Let's just write it. Okay, so what's the remaining area? So the remaining area is basically the area of the other triangle. I'm going to write the name of the triangle. It's ACD. So ACD is therefore equals to 375,000 minus 213,651. What's 375,000 minus 213,651? 161349. Can I see what the triangle looks like? It's a simple right angled triangle, so I don't need to worry a lot. What I can simply say is that this is the base and that is the height. So I'm going to just say half into base, which is AD, into height, which is 800, 161349. 161349 multiplied by 2 divided by 800. So AD comes out to be 403.4. So that's 403.4. Oh, in fact, I needed correct to three significant figures, so I'm just going to write 403. My bad. Okay. So 403. Let's check if that is the correct answer. Yes, 403 is the correct answer, although I should just make sure that I write down 403.37, which was there. So in case if I need to use it, I can use the exact form. Then it says calculate ACD. So I am asking you to calculate this angle. Let's call that Y. So I can just use the numbers that I just calculated, put it into tan, because I have the opposite and I have the hypotenuse. So 403.37 divided by 800. Okay. So tan inverse of 403.37 divided by 800. 26.757758 basically. So 26.8 degrees. Let's verify if that is indeed the correct answer. 26.8 degrees. Yes, is the correct answer. Then it says X is a point on DC. So I have all the other sides. Let's also write this down. It's 403.37. In case I missed that out, that angle is 26.8 degrees. It's 757. So I'm just going to write 76 just to be more precise. It says all of this is there, and then this is 500. Calculate the obtuse angle AXC. So I am looking for this angle. Let's call that small. We can call that X again, although I put an X earlier as well. I think then there's that simple 4-mark question. So it's going to be sine rule or cosine rule. I have two angles and I have two sides, which means it's the sine rule. So sine X over 800. Sine 26.676 over 500. So X therefore then comes out to be sine inverse of 800 sine 26.76 divided by 500. So I get 46.088. But you see, that's not an obtuse angle. I was asking you for an obtuse angle. So an obtuse angle will come out if I subtract it from 180. So I get 133.911, which is 133.9 degrees. Okay, moving on to the next question then. I have a lot of questions to do. Okay, let's look at this one. I think we've just reached 2 years right now. I have another 2 years of past papers to go. Okay, a light rail is fixed on a building 8 meters above the base B of the building. A point P is on the horizontal ground 12 meters from B. Calculate the angle of elevation of L from P. So I am asking you for this angle. Let's call that X. I think that's a simple question. I can just say that tan X is basically 8 over 12, opposite over adjacent. So X is therefore tan inverse of 8 over 12. .7 degrees. Okay. Then I have this question. It says the ladder L is placed on the ground at Q to reach the light L. The ladder makes an angle of 70 degrees with the ground. Okay. Calculate QL. So I think I'm just asking you for the hypotenuse. So you decide which trigonometric ratio you want to use. Sine 70 equals to 8 over hypotenuse. And just write 8 over QL. So QL is therefore 8 divided by sine 70. That gives you the most precise answer. Remember that. A lot of people have this confusion about, sort of writing moving sine and 70 together. That's how it's supposed to move. And so sine is a function. It's not supposed to get separated from 70 unless you're trying to find that angle, in which case it's sine x, and then you move it to the other side and you get sine inverse and so on. So what do I get here? I get 8.51. It's 8.513, so correct to three significant figures is 8.51. Okay, let's first check if those answers are correct. 8.51 and 33.7. 33.7 was my answer. Yes, 37. Okay, let's look at the third question. It says a vertical pole RS of length 1.6 meters is placed touching the horizontal ground. The light produces a shadow TS of the pole on the horizontal ground. LRT is a straight line and TP equals to 6.5. Okay, calculate TS. So I'm just asking you to calculate this length. Let's call that X again. Okay, now this is a case of similar triangles. You see these two triangles? Since it says vertical pole, that is why I drew a 90 degree. So these two triangles are both 90 degrees. They have two angles that are equal, 90 and 90, and one is the common angle that's at T. So that means that the third angle must also be equal. That proves that they are similar. So when you have similar triangles, the ratio of their sides is the same, which means that this perpendicular to the bigger perpendicular, 1.628, is going to have the same ratio as the smaller base to the larger base. So x over 6. This is just about cross multiplying then. So 1.6 into 6.5 divided by 8. So that gives me 1.3 meters. Okay, let's check if that is the correct answer. Where is it? Okay, 1.3. Okay, that's where I'm going to stop for now. There is going to be another video for trigonometry. I'm going to break it up into two videos so that you can watch them easily. Make sure to like and subscribe and follow for more videos. Thank you.